Straight in. So I've kind of put together a very kind of general presentation on scripting, and I'm just, as the title of the presentation kind of implies, it's an awareness of scripting. So there's some detail. I'm going to try and cover quite a broad range of the topic today, just trying to give you all a bit of a flavour of what you can do and the kind of things you need to be able to do to do that. I think like a key point to state is I'm an engineer. I'm not a computer scientist. I'm not a computer programmer. Everything I know about parametric design and scripting, I've self-taught myself or learned from others. So it is completely possible. My 5-year-old niece can script better than I can, so it's all pretty good. So we're going to go through what is scripting, the real basic scripting in Excel, and then we're going to look at visual scripting, particular Grasshopper. We're going to have a quick look at Dynamo, and then hopefully we'll be at the end and we'll be able to take some questions from the floor. So this lecture's kind of come about because I sit on the Digital Workflows and Computational Design panel, which is a bit of a mouthful, but out of that we have kind of said, well, actually scripting isn't really discussed a lot in the industry at the moment. It's not really discussed at any level. And so there's a series of lectures coming up. So this is the first one, which is kind of the awareness of scripting. And then Stephen is going to be doing one on the success and potential failures of the engineering computational design. And then at some point, Tim, I think he's on the 13th, Tim Lucas is going to be doing something on digital fabrication. I don't actually know what the title is, he didn't tell me, but that's what's going on. So I'm kind of interested in the room, and apologies to anybody who's listening online. You won't be able to see the answers of this. But I just want to get a feel for those in the room about your kind of positions within business at the moment. So if you can, when I go through the questions, you just raise your hands. And then the kind of work in terms of scripting, if any, that you're doing. So have we got any senior management in the room? Okay, so a handful, 4 or 5, perfect. And then what I would call project engineers, so those people who are client-facing or leading small teams, perfect, about 10 to 15. And then project juniors, so those who are kind of doing a lot of the number crunching on projects. How many of those have we got? Perfect. And then any others, so I guess students and anybody just interested in engineering generally. Perfect. So how many of you use Excel? Excel, right, near enough everybody, perfect. How many of you use Rhino? Okay, and then how many of you use Grasshopper? Okay, perfect, good. And then similar question, but with Revit and Dynamo. Okay, so every time it's about 10 to 15 people, and similar people are putting their hands up. And then the big one at the end, who uses digital projects? Good, I thought you'd say that because it's mega expensive, that is. And then is there anything else anybody's using, if anybody's using any other scripting tools? Okay, no, perfect. So where to start? What is scripting? Well, Wikipedia, always the go-to place, and it has this convoluted discussion on what scripting is, and it goes on for about 10 pages. To me, it is a series of computer programs, or effectively lists, that automate sequential tasks, and it makes you more efficient. And that is kind of the story I want to try and get through today, that scripting is not about making funky, fuzzy structures. It is a tool to get you there, and really what it's about is handling data and vast quantities of data. So common forms of scripting, and we've kind of gone through this already. Excel, and then within Excel there's macros, which are VBA or Visual Basic Scripting. There's a language for Rhino called Python, and there's also RhinoScript. And then obviously some of you might be using MATLAB for some of your technical work, or you may have used MATLAB as part of your studies to become an engineer. And then, so that's what I would call written script. So that is you writing down what you want the computer to do in a computer-based language. And then there's what I call visual scripting, which is Grasshopper and Dynamo. And that's really what I'm better at in terms of scripting. So when I say I can't script, if you ask me to sit here and write you a script in VBA, I could probably do a basic one for you, and I'd probably take about 2 days to do it. But if you were to ask me to do something in Grasshopper, I'd be much more competent. And that's more about the way my mind works, and the way that I think about how I put together information. So some people tend to be more aligned to written scripting, and others more aligned to visual scripting. And then at the bottom we've got parametric software, which is digital projects. So digital projects, there is some scripting involved, but it is essentially linking forms and shapes in a kind of pseudo Revit Rhino environment, but there's huge potential there to link geometry together and various other bits and pieces. So why script, I guess, is the kind of the big question. And as I've kind of already said, it automates those sequential tasks. So when you're thinking about your day-to-day lives and you're doing work and you're thinking, why on earth am I just repetitively doing tasks? When you're saying that to yourself, that is the point where you should be saying, I need to script this because it will save me time in a long time. And it will increase your efficiency. But I want to just put some words of caution out there. So I'm going to say a lot of good things about scripting and why you should do it. I'm going to put some caution in there. The first thing is, if you win a project and you think, great, this is a great time to just do some scripting, do some complex geometry, you will probably lose money on the project. Okay? And your bosses will probably be quite unhappy with you, and they'll probably give up on scripting straight away before it's even had a chance to take hold. So for me, companies generally need to invest in scripting. It's like a muscle. You wouldn't give a very complicated project to a graduate and expect them to deliver it. And it's the same way that you wouldn't give some complicated scripting to a graduate and expect them to just get on with it. Although the kind of graduates you're now getting out of university, they're all quite conversant in kind of the computer digital age. So those are kind of the key things here. I think if you're looking to do work which involves scripting, start baby steps, work up, and really develop that ability within your business. I guess the real big thing in here is scripts need to be QA'd. And that is the most important thing here. So whenever you do write scripts, they need to be effectively thought about, they need to be programmed, and then they need to be checked. And they need to be understood by others. So when you're scripting, you need to think about, can anybody else follow this script? And I know from my experience of checking other people's scripts and people checking my scripts, that it's very obvious to the person who's written that script, but actually for somebody else to come through it and understand what you've done. And don't forget that some of the scripts you might write within your business, say you're going to automate some calculations, that you might leave that business and 2 years later somebody needs to adjust it because there's been a change in Eurocode. And what you don't want is somebody to spend weeks and weeks and weeks trying to work out the code that you've written so that they can then change it. So before you start scripting, you need to have some very clear ideas about what you are trying to achieve. So what are your available inputs in terms of the information that you've got available to you or the assumptions you can make? And what are you trying to achieve with this script? Are you trying to get out point data for geometry? Are you trying to order data in a certain way to get results for forces from your analysis programs? And then think about what are your desired outputs. So who's this information going to? Is it going to another piece of software within your business? Is it going outside of the business? And if so, how do you then QA that? And then I guess the last two things is how much time do you have available? Because some methods of scripting are very, very complicated, but can be quicker. So let's start right at the beginning. And some of you in here who might not have scripted may actually find out that you have scripted in a way. So here's a problem for you. Rounding data in analysis projects, in Excel before putting it into an analysis program. So if you've got a series of data that you've pulled from an AutoCAD drawing that's been sent to you by an architect, you may find that the XYZ coordinates have been put into 1,000 decimal places, or you might have got some output from Rhino that's got decimal places to 1,000 points. So you need to work out, how can I round this efficiently? So some of you, the smart people in the room, will say, well, why don't you round it all using the rounding buttons in Excel? But what that actually doesn't do is round the answer. It just rounds it on the screen. So all you can see is a rounded answer. So if you progress from that, you'll say, well, actually, there's a function in Excel, and it's called mround. So you can use mround, put in the cell that you want to round, and then give it the available data that you want it to round to. In this case, mround A5 to 3 decimal places. And you run that. And on the example you can see on the screen, what that does is it rounds everything that's positive, and it gives it 3 decimal places. Everything that's negative, it now returns a num value. So it only solved half the problem. So let's now turn this into more of a script. So more complex logic functions. So what we're in here is saying, if A5 is greater than 0, mround it. And mround it to 3 decimal places. And if it's not equal to 0, mround it to minus 3 decimal places. And that solves your problem. This, to me, is one of the most useful scripts I've ever come across or ever sort of put together. Because a lot of the data we end up using, especially as engineers, and we're putting it into analytical programs, you tend to want to kind of round all of your numbers to 3 significant figures, whether that's in millimeters or meters, and processing that data before you do anything else with it. So moving on, macros. So macros are within Excel typically, and they use a language called VBA, so Visual Basic, which is Microsoft programming language. All programming languages have some similarities to them, and they also have a lot of differences to them, and it's very difficult to kind of know all the languages going forward. So my advice to you is to kind of choose one language and learn it, and then once you've kind of got that, then learn another one. So when I started out scripting, I worked with a colleague in Aecom, and we were looking at developing software for geometry generation, and we were using Excel at the time, and we were trying to do a proof of concept. So we were at the time trying to prove to the business that you can use scripting to automate processes. And so before we could get a significant amount of investment into what we were doing, we had to kind of prove that there was a kind of proof of concept there to do the work. So we used Excel. And I'm just going to take you through a very basic script here, talk you through the lines, and just give you some kind of understanding of what you can do with it. So first thing you need to do is you need to turn the macros panel on in Excel. Now that sounds like an easy thing to do, but it's kind of hidden away. So if you go to you need to put on the developer tab, so you have to go to Excel options, customize ribbon, and then turn on the developer tab, which is on the right hand side. Once you've got that, you've now got options to create and edit your macros. So at the time, when we were starting to do this proof of concept, we were looking at developing software to take data from the stiffness matrix of our analytical program and process that, put it into Excel so that we could run footfall vibration calculations from it. So this is part of that data, which is the eigenmodes. The eigenmodes we could get out of the software only came out in a fairly dull text file. And there was no comma delineation, so we couldn't just copy and paste the text file and paste it straight into Excel. So we had to find a way that you could write a script that copied all the data within the text file and then moved it around and put it in the right places within Excel. So this is the example. So we've taken the text, just Control A, copied, pasted it into Excel, and what it's done is it's dumped all the information in column A, and it's fairly useless. So if you look on the line with the information in it, you can see that basically the whole line of information is there, and it's fairly useless. The advantage we have here, though, is that the information has been pasted in such a way that there are a set number of spaces between the characters, and that is what we are going to use to kind of separate out this file. So here is the macro. There we go. And it might look quite complicated, but I'm just going to talk you through what it does, and you can kind of get an understanding for how you need to think about your approach to this work. So the first bit is the top line, submode underscore shapes. That is title. Doesn't do anything. It appears at the beginning, and it just says this is the title of this macro, and you can then assign that to buttons or whatever you want to do in Excel. Code in green is author's notes. So as I said earlier, it's key that when you're writing scripts that you kind of comment on them, note on them, so people understand what you've done, the decisions you've made, or in some cases, what it's doing. I picked up this code at the weekend to write this presentation, and it took me about 2 hours to work out what it was doing because I couldn't remember, and it was sort of 3-4 years since I'd looked at this piece of script, and so I thought to myself, that's a very good point. I should tell you to comment on your scripts. So what does it do? The first thing it does is it selects all the cells, so that's cells.select. And then it says delete, so that's cells.clear content. So what it does is it clears out the whole spreadsheet or that sheet of all the data. It then selects A1, and then it pastes. So what you need to have done, in the instance of this script, you had to already have copied your data. We could have set the macro to do that, but for various reasons we didn't. So it will then paste all of the information on the clipboard. So don't do what I did at the weekend, which is when I ran this, it then pasted a picture of one of our company projects in, because that was what was in the clipboard, and I had to open up the macro and close it and then reopen it again. So it selects the information and it then pastes it. It then selects the range, A1 to A6, which is here. Oh, go back. And then it clears the contents of those selected cells, and then it pastes and changes and it moves some bits around. And then the key bit, it is here. This is the actual bit that kind of makes the script do what it needs to do. So this takes the field in A1, so we said that all the data was pasted in A1, and it effectively splits that data by a series of fixed width arrays. So what it is saying is in array, OpenScore 0-1, it's saying starts in the cell on character 1, which is effectively 0. And then it's saying move along 1 character and place that in the first cell. And it's then saying in the next cell, start at the 10th character and move along 9 characters, and then that's it, that's what's in that cell. So what you're getting is a cell that's got one character's worth of data, then one that's got 9 characters worth of data, and then one that's got 1, 1, 1, 1, etc., etc., etc. But the first line is taking the characters from certain lines, certain positions in the lines, and taking them out and pasting them. So we'll see how that works in a minute. And then at the end it says, basically select all the data and format it. So here's some images. So first of all, it's selecting all the data. And a really nice point here is when you're running macros in Excel, you can get it to do a step macro. So you can press the button and it will try and play the whole macro. It will find an error, or it won't, or it will work, and it will all be done. If it finds an error, it will put up an error code, and you click OK, and then it basically closes it down, and you can't work out what the error is. So what you want to do is do a step play of your macro. So it works through every single line separately every time you press the key. So this is what I've done here to pull this information out. So moving forward, this is that section. So we were saying select cells A1 to A6. So you can see on the screen it's done that, and then it's deleting that data. And now you can see down on the bottom that all of the cells, all the information's been split up and dumped into the cells itself. So that original line of characters, which were 130 characters long, has all been split up and then divided into the cells. So it's very, very handy. It's a good way of taking dull text data with a very simple macro and using it to manipulate data into Excel. From there, you can then run it through all of your calculations and spreadsheets. Good. We progressed that quite simple scripting into more complicated scripting, where we were looking at generating geometry. And this is just a kind of an output of how complicated those scripts can look, but also the kind of data that you can get. So this was a complicated set of scripts that effectively, in this instance, plotted the geometry of a velodrome, and all we were getting from it was point data and beam data. So it was saying, here are all the points, and I want to connect this point to this point. Good. And here's some more bits and pieces. And that is the geometry generation. That is the analytical model. So that is the data straight from Excel, pasted into Excel, and there you have a fairly complicated building, which is almost ready to go for analysis once you put loadings in. We actually developed this so you could also put all the loadings in with it as well. Okay, visual scripting, the kind of showpiece of scripting as it sits at the moment. So I'm going to focus mainly on Rhino and Grasshopper because that's kind of what I know. I am going to cover a bit on Dynamo and Revit. I'll probably get shot for saying this, but they are kind of similar. They're a similar approach to scripting, and that is what I would call visual scripting. So Grasshopper, if you've got Rhino already, Grasshopper is free to download. So you can register at grasshopper3d.com and you can download the software. There is a huge online community, which is one of the best things about Grasshopper. If you have a problem, you can normally post something on one of the forums, and somebody will normally have either sorted it out or will go away and play around on their computer and send you a file back and say, oh yeah, this is how you do it. So it's a real good active community. If you are going to get involved in scripting, I suggest, especially if you're going to get involved in Grasshopper, I recommend you get involved in the communities, in the forums, because there's no point reinventing the wheel every time. Lots of people face exactly the same problems. And there are limitations with what you can do with some of the pieces of software. There are additional plugins at a website called Food for Rhino. So that's got a series of Rhino plugins, but it's also got Grasshopper plugins. So if you want to get something like Kangaroo, you can download it from there. And then there's really good online training from Design Reform as well as other websites. So I used Design Reform a lot when I was learning how to script. It's just got some good ways of showing you how to start looking at data and start thinking about data and how you start scripting. Okay. So, I'm going to show you a few bits and pieces in Grasshopper, and I'm going to kind of talk you through what's going on, why I've done certain things, and what some of the characters mean. But as a kind of overview to Rhino and Grasshopper, you can basically create data yourself from nothing, or you can input data, say from an external source, whether that's text files, whether that's Excel files, or you can take data straight out of Rhino. And for different things, you might take different approaches. You can then link all this data within Grasshopper to basically handle that data, manipulate it, and create parametric workflows. You can then output that data to something else. Analysis, to Revit, to Dynamo if you want to. But it does require a change in thought process. And this is particularly looking at geometry generation, but it kind of, you'll get a feel for what it means in terms of the scripting. And when I say it requires a change in thought process, I think a lot of people think, here is a beam. It has an end and a beginning. But actually what you need to start thinking of is, here is a point, and I can create a line from this point to another point, and that point has, well, point 1 has x1, y1, z1, and point 2 has coordinates x2, y2, z2. But also I can tell it to get to point 2 by giving it a vector or an angle and a magnitude. So instead of where you're used to thinking about point and click, maybe in Rhino or in AutoCAD or in Revit, now you've got much more powerful tools available to you. Now you can take angles and you can give things magnitude, and you can give things more physical properties that allow you to manipulate them in ways that you probably wouldn't have done previously. So when you open up when you open up Grasshopper, you have what's called the canvas, and this is the canvas. And it kind of looks a bit daunting. I would recommend, if you are looking to use Rhino, you either want a really, really big screen, so you can have Grasshopper and Rhino open at the same time, or split screens, so that you can have one open with the other. So anything you put into Grasshopper is then represented in red in Rhino. So you can use it to overlay on top of existing models, you can use it to pull information backwards and forwards. So I'm just going to go through some of the parameters and toolbars and just kind of explain to you what the data means, or what they do, or in kind of general. So at the beginning, you've got parameters. Parameters effectively holding objects, okay? And they do allow you to give some intelligence to your data. So if you take a geometry parameter, and we'll look at this more in detail at the example. So if I was to take one of those, say the circle one, which is the second one in from the right, that effectively will hold data as a circle. And if you look at the one which is an X on the edge, that is a point data. So I can pull point data into that function. It knows it's point data, and then it tells Grasshopper it's point data. And then when you're using it throughout the software, it knows that it's point data. Moving onwards, you got sets, which is on the right-hand side. This is all about manipulation of the data as a list. So you might pull in 10 points from Rhino. And you might think, actually, I only want the first 4 and the last 4 points. I don't want the middle 2. So you can use some of the functions in sets to manipulate that data, that list. And you can take parts of that list apart, you can split it, you can remove elements, you can reverse it. You can take it all apart, put it all back together again. Maths. It's kind of self-explanatory. So here are math functions. So if you want to do this parameter times this parameter, then this is the place to pull that data. At this point here, you can also script. So you can also pull in where it's got the C and the VB, that is Visual Basic, and it's C+. So you can use that to actually script. So if you're more of if you want to do a bit of visual scripting, but you're more of a kind of righty scripty person, then that is the functions for you. Moving on, you've got vector. Vector is all about controlling data. So it's about controlling the plane and the vectors that you're using, so you can set well planes. So for example here, if I was to use plane data, I can set the XY, XZ, YZ data, so it tells the computer which orientation you want things to move, how you want to manipulate that data. So I'm just going to go through the last 4. I'm not going to go through transform on display, because that's transform on display is for another day, definitely. So curve, that is all about information what to do to curves. So if you want to split curves and manipulate curves, find points on curves, pull curves, adjust them, then curve data is what you want in there. You've then got surface data, which is effectively similar to curves, but it uses functions to either create curves, surfaces between curves, surfaces between points, or fixed kind of size surfaces. So if you wanted to create a cylinder, there's a function for cylinder. Meshing. Meshing is an interesting one, and I typically don't tend to use meshing too much. It's often used by architects to kind of mesh surfaces to create panelization. You can use meshing to some degree successfully to import data into something like GSA or SAP, where you can manipulate your FE model, your FE mesh, and you want to create an FE mesh. I think John Murchison has created a number of tools that plug into Grasshopper that you can use to now output into various other pieces of analytical software. And then intersect is fairly self-explanatory. So you've got mathematical intersections, so that's kind of intersections which you might be intersecting a line with a plane or with a surface, and then you've got physical, which would be like a line with a line, and then you've got regions and shapes. Okay, good. Moving forward. A wheel roof, a basic example, and this is possibly, I think, as basic as a set of functions can get to create a structure. You may disagree. So here is the Grasshopper script that defines this form. And it might look, if people aren't familiar at looking at Grasshopper, you might think, oh my God, I don't understand what this means. But it's okay, I'm going to explain it to you. So what is it doing? There are 4 key parts of this, 2 bits I've highlighted twice just to indicate the big circle and the little circle. So on the left-hand side, in the green and the blue, we've got the definition of the inner and outer constraints. So the big circle and the little circle. The next function in the middle takes the inner circle, moves it up, and moves it down at the same time. And the blue chunk on the end takes all the circles and splits them. And then the last chunk reorders the point data and then connects it all together with lines. So it's a very simple thought process. So we've got some inputs, we've got some messing around in the middle, which is the kind of the heart of the script, and then at the end there's the output, which is effectively XYZ coordinate data, and point 1 connects to point 2. So defines the outer circle, defines the inner circle, moves the inner circle, splits the curves into segments, and takes segments to design and defines the centerline data. Centerline data, I think, is very important for engineers. We tend to work on centerline data. Many other people who script in the industry don't. They tend to work on surfaces. There is no right or wrong way of doing it, but if you're doing geometry like this to put into a piece of software, it's much easier for things to intersect when you start working with curves rather than surfaces. And ultimately, you want your data to intersect so that when you put it into your analysis software, if that is what you're using it for, that you don't find that you've got an unstable structure because none of the points intersect. And depending on the accuracy and the kind of the fiddly nature of maybe your analytical programs, you might only need to be off by 0.5 of a millimeter and your scripts effectively fall down. So, circle definition, what does this mean? This is the function for a circle. This defines the center point of the function, of the circle, and the system plane. So this is a plane function. It says, I want to work in the XY plane, and I'm going to plug into that either a point for my center point. It defaults to 0, 0, 0, but you could effectively say, I want it to be at well coordinates for my site, and that is whatever it's, 1000x, 1,000,000y, and 25z. And then the slider. So the radius outer slider here, which says 60,000 at the moment, all that's doing is just controlling the magnitude of how big that radius becomes. So looking at the translation, this function is taking my radius and timesing it by 2. And I'm now dividing it by what I'm calling effectively, and this is my span to depth. So I was using this to play around with how much space do I want between my inner upper circle and my inner lower circle. And I just set this up as take my radius, divide it by a set amount, and that's what I want it to move. The function in the middle is a vector. So it's saying move this data in Z by the amount that's plugged into it. So the amount that's going into that in this is 5,000 millimeters. So it's moving 5,000 millimeters. Okay, so the last section is a transform piece of is a transform function. So it's taking the curve geometry and it's moving it by the amount of the vector. And the top one is moving it up and the bottom one is moving it down. And the difference between the two is indicated by the star. And the star says input times -1. So all it's doing is taking the same data and just telling it to be times by -1, and then it goes. So, segments and curves. This literally takes the data and divides it into a number of set lengths, indicated by the value n, in this case 20. So I've now got my outer circle with 20 points on it, all starting in the same position. I've now got my inner circle split with 20 points, all starting in the same position. And then all I'm doing is saying, connect all of these pieces together, connect all the ones inside and outside of the rings together, and then create lines. So that's what that gives me, because of the way it's set up, is the ability to control the geometry now. So this is just a little video of me playing around with some of the sliders, moving things up and down, opening things up. So using this quite simple script, I can now look at a bicycle wheel roof. I can play around with the radius. I can play around with the inner radius, the outer radius, the number of segments. So in this case would be the number of cables, the number of kind of intermediate cables in between. I could actually turn this into a trussed roof with 2 minor changes to the script. So now I've got here quite a powerful piece of geometry that I can use to test options. So I can say to an architect very quickly, well look, we can either do the roof as a span to depth and have a 10 meter depth in the middle, or we might need 12 or 13. The difference in efficiency is Y. And you can feed this data through your analytical models very, very quickly. And once you've got to this point, probably produce 3 or 4, 5, 10 scheme designs in a very short period of time. And also give some certainty as to what the right design is in terms of the convergence of the structural solution. So in here, I could have said, well, actually, if we keep the depth, the middle of the structure the same, what is the increase of efficiency if I reduce the radius of the inner circle by 1 meter, and then another meter, and then another meter? And I can keep running that through this. I can then take the data via Excel, and I can put it into GSA, into SEER, into SAP, and I can reanalyze the model. If I don't change the number of nodes in the model, I don't actually need to change anything in the model itself, in the analytical model itself. I could probably just paste the geometrical data back over the coordinates. So on the assumption that there's no more nodes, I can just move the nodes as I need to per model. So once I've got one set up in an analytical program, I can then run it, change the data, save it, run it again, etc. So, uses of bringing data into So that we looked at taking data, creating data from nothing effectively within Grasshopper and creating a structural form. This is now an example of taking data from Rhino and trying to get it to a form that you can actually use it to import into an analysis software. So this is an example from when I was at Aecom. This is the Serpentine Pavilion 2013. This is the initial model we received from the architectural team. And it had something like 40,000 members in it. And when you tried to take the Rhino model they sent us, export it as a DWG, import it into the analytical program, select all the lines to try and create a structural model and tell it to convert them to structural members. The whole thing hemorrhaged, exceeded all the memory capacity of the computer. So we had to think about a smarter way of doing it. So this was one of my first forays into visual scripting using Grasshopper. So if I just click play on here again, so you can see in here like just the level of complexity in the model. Also, we need to check this model for errors. So we are putting a lot of trust in the architect here that all of this is modeled correctly, and actually using Grasshopper is a really good way to get a good sense check onto how accurate a model is. this building was built on a module of 400 and 800. So we knew that if you could export out the coordinates of every single point in this model, you could check because it should sit on a multiple of 400 or 800. So you could take the data out, and I'll show you how I got the XY geometry out. But you could take that, put that into Excel, basically write a function that says divide by 400, and if you've got a whole number, then the geometry works. If you've got a non-whole number there, then you can say, well, actually, some of these sections or elements are not sat on the grid, and hence there must be an error in the program. So, how do we do it? So this is the model on the left-hand side. On the right-hand side is the Grasshopper script. And theoretically, the Grasshopper script is just the first two functions. So what do they do? The function on the left-hand side is a data function. So as I said at the beginning, we spoke about parameters, and some of the parameters are empty, and all they are there are to use data, store data, or collect data. So in this instance, the curve data, and my advice in using Grasshopper is to always use curve, don't use line, because line's quite restrictive, but curve isn't. I don't know why, but that is the case. So take the curve function, right-click on the curve function, and it says select multiple data. So you can then drop into Rhino, select all the data you want, right-click again, and it dumps all of that information into Grasshopper. And then all I've done here is just run every single curve into a function called endpoints. So it takes a line, and it tells you what the start point is and the end point is, and it just gives you an XYZ coordinate. And if you look on the top, I've got some yellow panels there, and it's basically telling you what's in that data. There's the finished project. So more complicated scripts. So we kind of mentioned at the beginning, I worked on Wakrah, which is part of the Qatar 2022 bid. You may know it under a different name, that one. But this is the script for the roof at Wakrah. And it looks really complicated, and it is quite complicated. And on the left-hand side, there's various parts of the script. But what's really nice about this is the script is quite nicely laid out. It's quite neat, and it's quite tidy, and it's actually annotated, although I've turned a lot of the annotation off. So at any point, the person who wrote this script could go back in and change it. Anybody else in the team could go back in and look at that script and adjust it. But the key thing about this is, whilst it looks really complicated, the actual geometry is based on 6 curves, which are here. The bottom one's actually 2, but I joined 2 lines together by accident. So all of this geometry that you see on the left-hand side, all of the scripting that defines every single part of those trusses, intersecting trusses, the garages, the central truss, the supports, which is defined in the big script on the left-hand side, starts from 6 basic curve parameters, which are then mirrored around the structure. Okay, second example where things are useful, and I'm not going to go into the detail of surfaces and panalisation, because it's quite a complicated subject and it's quite painful, and it could happily eat up 2 or 3 hours of the lecture. On the left-hand side is the architect's model. On the top right-hand side is the panelized data within Grasshopper. So we've taken the surface from the architect and we've split it using a number of different functions within Grasshopper. So it's red. So when things are in red in the screen in Rhino, that means they're kind of theoretical. And what you can do is do something called baking. So you select a geometry element and you right-click and you say bake. And what that means is it just means make it fixed, and it fixes it in Rhino. So if you bake something, it then becomes real in Rhino, and you'll be able to manipulate it in Rhino itself. And so on the bottom left-hand side is the panelized structure before we then exported it out and put it into analysis software. There is the finished pavilion. Dynamo. Now, I think what I'm going to show you here is slightly different to what we've looked at in Rhino and Grasshopper. So my background is kind of been creating, geometry and looking at pushing data between a geometrical generation program like Grasshopper, and then putting it into either Revit or into an analytical package. But you can do that as well in Dynamo, and I'm going to go through a few different examples of doing that. But what I really want to focus on is things that you can take away from here today, go to your bosses in your companies and say, I was at this presentation last night where you know that project we worked on, and they said, can you change all the drawing numbers, please? And we said, oh, we didn't want to do that, and it was going to take forever, and they didn't want to pay us for doing it, blah, 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 blah. Well, Dynamo, if you set it up correctly, can change all of your drawing numbers for you pretty quickly in the space of about 10 or 15 minutes. So you can still charge the client for doing it. I'm not going to stop you from doing that, but you can actually save some time for doing it. So you can go back to your bosses and say, why are we wasting all this time manually updating drawings? Why are we messing around with drawing numbers when actually what we can be doing is automating the process and getting on with actually making sure that the model is correct, that the drawings look right. So at Web Yates, we do one of two things. We do two things. One is we link Revit via Dynamo to our issuing piece of software, which we use Newformer, and we can do vice versa. So we can actually create all of the drawing numbers in Newformer, which exports them to Excel, which then can be taken by Dynamo and put into Revit. There is an example of that. So on the left-hand side is all the sheets in Revit. The middle section is effectively all of our drawing numbers controlled in Excel, and on the right-hand side is the script, which I wasn't going to show you the detail of that, but you can work it all out for yourselves. So bulk renaming drawings. So when we process this, Dynamo goes within functions within Revit and starts adjusting the parameters. So not only will it rename the drawings within Revit itself, you can do a bulk export. You can then use Dynamo to renumber and rename all of your drawings in Revit, because Revit is annoying and it does things like exports all your drawings to PDFs in some kind of quite bizarre code in terms of the naming functions. So we can get over that. There is the script that does that. Perfect. And just to show that Revit can do, or say Revit Dynamo can do similar things to Grasshopper and Rhino, Dynamo to Revit. So this is Serpentine Pavilion 2015, Selgas Kano one. And we used this pavilion as an example to show how you can take geometry, and very complicated geometry, and put it into Revit in an efficient way. And Revit is an exceptionally good production tool, but without Dynamo, it can be exceptionally difficult to put in complicated geometry into that. And the addition to Dynamo to Revit allows you to not only put in complicated geometry, but it also allows you to directly assign data to parameters. And that to me is more powerful than just getting geometry in. So you can use Dynamo to put all your member end forces on into your model. And we did that on the Wakrah project to prove a point. And the point we proved on that project was the client wanted the most sophisticated BIM model that the world has ever seen. He didn't really want any drawings. He wanted all the data in the Revit model. So we gave him all the data in the Revit model, including all the member end forces, all the specifications, and everything that goes with that. And then we got a phone call that said, oh, our supply chain needs drawings. So, but with the industry moving forward and moving into a kind of digital age of BIM, and really putting more data into the models that we are creating, then Dynamo really helps to effectively link parameters within Revit to data outside of Revit. So some companies are using Grasshopper to create their geometry. It's a little bit easier, especially if people are used to doing that. You can then export that out into a common function, or you can export directly from Grasshopper into Dynamo. I don't know if I put it in, I didn't. There's a function that used to be called mantis shrimp. Everything to do with Grasshopper seems to be named after some sort of insect or animal. But you can move the data around to different places. So some people are working Excel, they're going into Grasshopper, manipulating the data, putting it out into Dynamo, coming back into Grasshopper. And really, it's for you guys to decide what works best for you, what works best for your company, what are you trying to achieve. A workflow that we developed at Aecom, and this is one of many, but this one is particularly nice because it uses a number of the programs. So here we were receiving information on the facade in Rhino, and we were using Rhino to acquire the points. We were then using Excel to extract the data, the points of a spreadsheet. We were then using Dynamo to rebuild that geometry and input it into Revit. Because two things. One, the project was being delivered in Revit, and we didn't have enough Rhino licenses for everybody in the business to open it up. So we did have enough Revit licenses, so we wanted people who wanted to be able to get access to it to have it in Revit. And that is almost it. So I think I'm happy to take questions. I know it was kind of a brief overview, and I know that some of you here may be much more experienced at scripting, and this might have been a bit basic for you, but for others it's hopefully a nice introduction.
Thank you very much, Tom. I'll open the floor to any questions. If you maybe just give your name so that we have it on record before you ask the question, I'd appreciate it. And I'm sure Tom will facilitate us by answering whatever question you might have. I found it all very interesting. It's a long way from just looking at a sheet of graph paper and a couple of points on a bending moment diagram and trying to figure out what to do with a steel beam, but no doubt it all made a lot of sense to some of you. So I'm sure, as I said, Tom will have lots of questions, be able to answer lots of questions from you. So I leave it open to the floor.
Adam, nice. Straight in.
Hello, Adam Bradshaw, BDP, and previously Aecom. I'd like to ask you a question about the staff that use scripting.
Yep.
I am of the older generation that I've got a technical background, but I've passed that now. Do you feel that it's a specialist sort of person that does scripting, or is it going to be a general skill that all new young engineers are going to use?
It's a really good question. I don't think there's a right or wrong answer. I am definitely of the opinion that you get better engineering from an engineer who scripts than from somebody who studied computer programming, computer sciences, and is being used in a team to produce script for use in design. I guess, there are a number of different generations within the industry, and there are generations that don't want to use a computer and will tell you, look, faxes were the be-all and end-all of everything, and before that, telegrams. And there's people coming into the industry who, straight out of university, can write the most fantastic apps and do things that we can only dream of. I think with the way that junior and primary and secondary school education is going, people are going to be coming into university in 5 to 10 years' time with much more awareness of how to script and the functions of programming. And I guess people now, when they're going and doing their careers, sort of exercises at school, are being told, well, you should do scripting because the future is going to be run by computers. I personally see that over the next 10 to 15 years, the industry is only going to get better at scripting, and that will be driven by graduates coming forward. So do I see it as generalist or specialist? I think probably most people would say at the moment, those doing it regularly develop it as a specialism and will get, in their companies, get pushed to work on certain pieces of work because of that. I guess there's certain companies that are doing more specialist work. So, the engineering team at Foster's, I imagine, are doing quite a lot of Grasshopper, Dynamo every day just to be keeping up with the architectural forms that they're being given. Same with other practices, whereas maybe some of the small practices, there's maybe 1 or 2 people in that practice who can dabble and play around. But I think going forward, everybody will be writing their own scripts in the next 10, 15 years.
Hi, my name is Helen. I work at Foster's, actually, so thanks for mentioning it. I'm not going to speak for the whole team, but I do use Rhino, Grasshopper, and Dynamo on a regular basis. I find it really interesting that you mentioned QA, because scripting is quite trendy at the moment, and you're the first person I've heard speaking about QA. In my experience, I found it difficult to, I guess it's the same for everybody, to actually document the scripts enough so that they can be reused efficiently. Most of the time what happens is you take a script as an example and then you sort of adapt it and and try to reuse bits of it, but it's really difficult to find something that's immediately reusable and standardized and everything. What's your opinion on how that's going to develop? Because I found that it's a big obstacle in convincing people that scripting is actually useful.
Okay. Say hi to Andy for me. He did text me before. So one of the scripts that you saw up on the screen was developed by one of the guys at Foster's, Andy Coward. I think it's an interesting problem. I think many of you who work here will work for companies that are 9001 registered. And as part of your 9001 criteria, you must be QAing everything that leaves your office. Hence, you should QA your models. I get really frustrated when I hear of stories where people say things like, oh, the BIM model was wrong, or, oh, it was Revit that did this. And computer programs don't do things on their own. You have to be responsible for the information that leaves your office. That is why I mentioned QAing. And everything we do must be QA'd. Otherwise, there is no validity to what we're sending out the office. In terms of reuse of scripts, by their very nature, they become bespoke to a project, especially when you're looking at something like Rhino and Grasshopper, and the equivalent in Dynamo. So it really depends what you're setting up the script to do. And what you might find is that you save parts of scripts because they do something that's quite helpful. So, for example, I've got an Excel exporter that I've written, and I've got that saved as a separate script in Grasshopper, and every time I need it, I just open it up, copy it across, plug it in, brilliant. And you can create generic forming scripts like the wheel roof, which is I actually wrote at the weekend for a bid that we're doing. And it was quite nice that I was doing that at the same time as writing the presentation, and so it kind of tallied along with, I thought, a lot of the questions we'd get going forward. I think when you look at your scripts, and I see this a lot with the team I used to work with at Aecom, that the scripts get too big and they become really unwieldy, and they become across the whole canvas, like the one you saw for our Wakrah. And on that one, you make one little change and you might as well, go home, because it take 2 hours for all the data to process through. So it really depends on how you script. If you want things to be reusable, you have to think bigger picture, non-project specific, and create scripts externally that you then bring into the software and then make bespoke to that project. So you change them in there, or you don't, or you accept that when you're doing visual scripting, especially, it's very unique and very specific to the problem. I think when you're thinking about scripting in the wider context, so you're thinking about linking programs together, then by its very nature, it's reusable. So if you write a piece of software, a script that links your data from a text file to your analytical software, so whether it's GSA or SAP or CA or Robot or whatever, then that can be reused and reused and reused and reused and reused, because it's not dependent on anything specific. Is only dependent probably on XYZ data and node numbers and forces, or whatever you're trying to move from one piece of software to the other. So as long as you're aligning your outputs with your inputs to the next piece of scripting, then it's completely reusable. I think going forward, the use of scripting in engineering is going to make buildings much more complicated and much more bizarre forms. And because of that, they even need to put more parameters, more ability to create functions within the software that are bespoke. That are not bespoke, that you can pre-write, so that you can save those and pull those off of your toolbars, etc. Or we just have to accept that a lot of it's going to be sort of reinventing the wheel on every project. That makes sense.
I suppose maybe I'm sorry, my thought, I'm not super clear on this, but maybe the background of my question is maybe a question of skill, and maybe we're not quite there yet in terms of skill, even for example, senior manager to be able to QA our scripts, they need to have a certain awareness of it, and given that we're not computer scientists and we're not expert in programming, yep. I think it's kind of a difficult question, and it goes back to the previous question.
I think you're right. Scripting is quite personal. I've got a very good friend who works for Goldman Sachs, and he works in their programming department, and they write various bits of software, and he spends his life trying to work out what was done 10 years ago on a really old piece of software that's broken down. It's got people screaming at him because the company's losing money. And it's impossible, and that's an established industry where they're writing their own software forever. I think because it's such a personalised thing, the only way you can QA a script effectively is for you to go through the script with your manager. This function does this, here is the output. How do you test if that output is correct? Well, you have to have some way of looking at the end answer and saying, is that within valid parameters? So if you were, say, let's say you were linking you were doing some maybe dynamic relaxation of a structure, and you were linking your analysis software because it doesn't do it with an Excel spreadsheet, and it starts kicking the data backwards and forwards between the two. Before you even start that process, you should have a fairly good idea of what the answer should be. And so, we're not stopping, you should know what the answer is. Probably some of the senior managers in the room here probably can't power the analysis software that you're using anyway. So how do they QA that? They sit with you with the screen and they go, that should be a pin connection, why have you got a moment there? So it's exactly the same process. So I think you can do it, but you have to guide your senior managers through that QAing process at this point in time. I think going forward, I think everyone will have much more awareness of it.
Hi, I'm Francisco Mena from Elliott Wood Engineers. Had two questions actually. The first one is which points in common did you find in your experience between managing a team of engineers working on a building project or whatever the project and working on a script? So how do you manage or organize that team working around the script?
Okay, so you're effectively saying, how do you have a team scripting and how do you get them to pull scripts together? Okay, perfect. It's an interesting question, and again, it's an interesting problem. You either got to do one or two things. You've either got to set out your team's objectives at the beginning. So you've got to sit around and say, what are we trying to achieve here? So if you are trying to achieve some geometry, what is it you need outputted from that geometry? And when you look at the geometry, can you separate it into two parts? You can't have two people working on the same script at the same point in time. It just doesn't work. One, the software doesn't allow it to happen, but if you were coding it, it just would be horrendous. So you have to look at what the problem is and say, how do we separate this problem into manageable chunks that you can script and you can script and you can script, and your output from here feeds into the input here? Because you can create test data that you can move between scripts and say, well, okay, for you to build this script, here's the test data. Well, you know that your input is going to be X, Y, Z coordinates, and you know that your input is going to be moments. And so you can subdivide your scripts to try and create a framework. And then you can effectively mock up the data in between those scripts so that people can test them and check their outputs. If I'm really honest, the most successful scripts are written by one person. And that our Wakrah script that you see there is written 90% by one person. And on that job, that was all they did, day in, day out, which is great. But actually, the real downside of that is if we had to revisit that script a year later and he wasn't around, then it, problems. I think that problem, when scripting becomes much more diverse within the industry, the software will have to change in a similar way, maybe to the way that Revit allows multiple people to work at the same time on a single script or creating a script. But then maybe if you need that many people writing a script, maybe the script's too complicated and maybe it needs to be simplified. People designed really quite complicated buildings before computers were really invented. So, it can be done. It's just a case of whether you're scripting part of the structure. Let's take complex geometry, and it's probably the easiest one to kind of use as an analogy. Do you need to process all the data in a script, or do you just need part of it? And I think it's up to the manager working with the team, understanding the skills of his team or her team, and putting together an action plan, the same way that you plan doing a project. You'd have a big skyscraper, take the Shard that's not designed by one person. There's multiple teams working there, feeding information between each other, looking at specific elements, and that's the same in scripting. It's no different.
And, sorry, second question then is how long do you think will take to the parametric scripting to get actually to the offsite manufacturing, so you can script the robots manufacturing?
So you're talking scripting to maybe
getting that scripting one step further.
To go
so actually
maybe
you
to
are
like 3D printed on site or whatever. Depending on the projects you use, or you're doing and who you're working with, some places it's more capable and others it's not. That Serpentine Pavilion project, there was only ever one drawing produced for that, and that was the setting out plan for the foundation for the concrete slab. All of the superstructure was fabricated from 3D models and scripting. But then the capability of the company to do that was high and specialist, and not every contractor is that. It depends, I think, on the type of structure, whereabouts in the world you are, the appetite of the contractor, the appetite of the client to do that. I suspect we're 10, 15 years away from it being anywhere near regular occurrence that that's happening. I think we're much closer to getting, when I first joined the industry, God, I sound old. The steel fabricators would never take your structural model. They'd never take it. They'd always want to create their own model from scratch. And now they're much more happy, or happier in general, to take your model and use it to develop their model from. They might still recreate parts of it, but there's a much more openness in terms of sharing models. I think Tim will have something to say. Tim Lucas from Price & Myers, he's doing a thing on digital fabrication, which will be really around the use of digital projects and fabricating in steel. And maybe it'd be interesting to get his opinion on it. I know that he has had some good successes, and he's had some pretty bad ones as well, where they set their own office on fire. So, yeah, it's an interesting problem, and I think it depends on how niche or how wide. I think niche projects you're probably much closer than maybe more kind of mainstream projects.
Sorry, just behind you there, I think.
I think you pretty much answered my question. Vladimir here from Covey. My question is more, as you said, there's normally one person doing the script and one person in the company, or a few, very small group of people who are very proficient at scripting and developing, and the rest is sort of at a very low level. How would you sort of disseminate, sort of spread out that knowledge from one really proficient person to everyone, and sort of develop steps of skills? How do you see that?
Okay. When I was working at Aecom, we set up the sports team with a kind of core identity of effectively scripting and creating complex geometry. We wanted everybody to be able to do some level of scripting and complex geometry work, all the way through to the directors and the associate directors. And the reason for that was, one, so everybody had a really good understanding of what they were doing and what the problems were in the process. But also because you'd quite often have to divert off the project you were doing to do a concept design for something else. And so everybody needed to be able to produce their own geometry, to analyse their own geometry, and then effectively create ideas, scheme designs going forward. And that worked really well for what we called that at the time. We called that rapid prototyping. And so that was effectively what I showed you there with the wheel roof, where you're creating a very simple form, very simple model to test some ideas and maybe look at, how do you adjust this structure in a kind of controlled way. But actually, when you then move into the detailed design of a project, there's so much scripting and so much ownership that you need of the model and the geometry coming through that script, that you can really only ever have one person working on it. So whilst I was saying that you kind of have one person working on it, you maybe per project. So you might then have somebody else working full time on another project doing the geometry, and potentially even analysing that geometry. In terms of the dissemination of that knowledge, so if you were working for a smaller company and there's maybe one or two people there who have got a kind of interest in it or are doing the geometry, the kind of scripting and the scripting work, there's a few ways they can disseminate that knowledge. The easiest one is the same way that you would do it with a structural package. So you say to somebody, here's the kind of basic controls, especially if you're looking at Rhino or Dynamo, here are the kind of basic controls. Here's some websites, here's some YouTube videos to look at. Go away, hide away in a meeting room for a day, play around with it, see what you can come up with. When you've got problems, we'll come and we'll sort them out. It's no different to how you disseminate information when you've got a new piece of software. I suspect, and maybe another show of hands in the room, who here does this sort of thing in their own time, outside of work hours, either in the office on the work computers or at home? Perfect. And that, I think, is kind of very atypical of the industry. A lot of people who are into this kind of work are doing it on their weekends, are doing it in their evenings because they're interested in it. And that is the best way to get people going, is to say to people, look, guys, look, I know all the Rhino licenses are tied up during the day because you only got 2, we only got 3, or only got 4, but if you want to play around with it, do it. Play around with the evenings, download Grasshopper, look at some of the websites and play around with some forms. That's the way I taught myself how to use it. And you make some mistakes, you go online, you talk on one of the forums to somebody, I've got this problem, they come back and say, oh, right there, no, it's kind of a known problem, here's a workaround for it, and you're like, brilliant, thank you. And it's a really engaging community out there for the scripting, especially amongst architects and engineers. And they're probably the best place to really kind of help to have a go, hit a brick wall, get somebody to help you out, either in your office or outside of your office, and then go forward from there.
Thanks.
Further back again, there's...
Andrew Blackie from Price and Myers. I was wondering, how do you assess whether the scale of a project's appropriate to implement scripting rather than just choosing traditional methods?
That's a good question. I would say there's no hard and fast rules on that, and it would be totally down to the capability available at that point in time. When you look at your resourcing throughout your company, probably depend on the director that's in charge, whether they have an interest or don't have an interest in scripting. I think one of the issues we have at the moment is when you look at the senior management of some companies, they don't see the value in it, and hence they're never going to push it. And so if a project came into one team in a company, they might use it, and when it comes into a different team, they might not use it. And I think it's totally dependent on the company and the people, the personnel available and the personnel leading the project. Personally, I don't think there's a scale or size or complexity of project that suits it. But you need to be totally flexible to kind of know when to use it and when not to use it, and that comes from experience as well. So I've used Grasshopper on projects and ended up kind of backing myself into a bit of a corner and having to spend evenings and weekends trying to get myself out of that corner. But that's when you're looking at maybe something like complex geometry and you're using those kind of bigger toolkits. We shouldn't forget that you can use scripting to just get software to talk to each other. And if your experiences within your companies are anything like mine, none of the software talks to each other properly. There are always issues with using, taking information from GSA and trying to put it into Revit by using a Revit link. They don't work. A lot of the time the data doesn't transfer the way you want it to, but you can script it yourself if you want to. You can get into the API of Revit, and you can effectively push the data through the system. Dynamo helps that now. You don't have to do what we used to do, and none of the software manufacturers will thank me for this, but to be honest, you can transfer geometry between any piece of software via Dynamo into Revit, as long as you get it into the right format. So I think there are processes that all companies can put in place, irrespective of the projects they do. Things like renaming of drawings, things like transfer of data between certain programs, which totally takes out scale and complexity out of a project. And that just becomes part of the everyday process for getting from A to E via B, C, and D. But actually we just decided that B, C, and D are a waste of time. We'll just go straight from A to E.
Two here on the left.
Hi, I'm Harry Bocking from Ramble. Just going back to the QA and also the fact you said, do you think buildings in general are going to become more bizarre over the years? Do you think contractors are prepared for that? So you can make these beautiful, really, really highly optimized structures, and it might get to site and they whack it with a hammer to get it in place so they can put the bolts in or something, and that's all your scripting gone out the window. And also, are they prepared to build all these fantastic structures, and is it going to be a challenge in the future?
I think contractors are changing. In fact, in many ways, contractors, where I think when BIM first came in, I think everyone thought that the contractors wouldn't get on board with it, and now BIM is being led by the contractors because they see the value in it. Who knows with scripting? I think with the complex structures, if they're that concerned about it, they'll just charge more money and the projects will become more expensive. I suspect in a competitive marketplace, which is where we're all kind of working at the moment, that people will find ways to build the projects that we're designing and the architects want and the clients want. If the client is asked for a Rolls-Royce project from his design team, he's going to ask that from the contractor, and at the end of the day, the money will talk and they will deliver the project, however that is done. I think it's up to us to kind of be proactive in the industry to really push forward digital fabrication, parametric design, scripting, and push it forward to the industry so that everybody's much more aware of it and the benefits of it and the pitfalls of doing those kind of approaches, so that the whole industry as a whole becomes technically more competent in those areas, and then the contractors will join in with that. I think I would say that it's contractors that are pushing BIM rather than the other way around.
Just actually on that, this afternoon we had an engineering leadership group meeting, and there was a small bit of discussion about errors occurring with contractors and whether or not we should, as an industry or as an institution, have some people come together to discuss among ourselves and with contractors as to how we might address some of these things. If you look very often at some of the mistakes or some of the accidents and collapses that occur, it very often it's something simple that was something maybe that was slightly complex in the initial understanding of the structure, and it was somebody set about trying to simplify it, either to construct it or to make it fit together, and it was that simplification very often led to disaster. And it as I say, it's very often just something simple that has gone wrong, or something simple that has been put in place to have a look at. If you look, for instance, at what happened in the Hyatt Regency Hotel balcony collapse over 20 years ago now, I mean, that was a very simple substitution that it was agreed between the contractor and one of the supervising people, and it was just a simple change that they made to facilitate construction. The concept that they had was probably correct, but it was just, as I say, just a simple correction or a simple change that was made that led to the disaster. And as I say, that it's very often just a change in the simplicity of what you're trying to do that can lead to complications. And the scripting and this facility that it brings in may not scare the contractor in the overall context, but very often by the time it gets down the line and it gets to the last fabricator that has to put the last half dozen bolts together, and suddenly he finds that only 4 will fit, and then it's the stroke of a hammer, or it's something maybe to burn out an extra hole or whatever. That then, how you get to the stage that you prevent that from happening is maybe an issue that we in the industry have to look at maybe at another day. But that's, as I say, is quite frequently when you look at things like the Cross website, it's generally something simple that has gone wrong. No, sorry, there was somebody here. Yeah, sorry, just here.
I'm Andrew Fraser from Ramble. Just a question on mathematics. I mean, do you think having a good understanding of applied mathematics is really important, or is visual scripting actually a way of avoiding understanding mathematics, or does it actually matter? And just kind of your view on that.
discuss. Okay.
For 20 minutes.
I personally, I'll talk from a personal perspective. I can't script. I can do some very basic scripting in VBA, bit of Rhino script. But I can fly on Grasshopper because it's visual and it works the way my brain works, which is this plugs into this plugs into this, and I want this to happen, so I do this and I do this and I do this. So do I think a kind of applied mathematics approach to this works?
Well, it's more, do you need a good understanding?
No, I don't think so. No, I think you need to have a good feel for form. Fundamentally, the thing that drives what we should be doing with this software is not playing around to create a shape. We should be taking structural principles and applying them to a form and correcting a form and sending it back and manipulating that form. You know, architects tend to use Rhino a lot and create form. They don't have a real understanding of applied mathematics, and they have a kind of rough guide feel for, maybe we should, spans of this and this, and we'll draw this funky shape, send it to the engineers. To do the really complicated design principles, then having an understanding about how you form a shape in mathematical principles helps. But software like Rhino and Grasshopper take people who they might struggle with that, and they creates a visual environment which they can work in that. I don't think you need to have it. I do think you need to have a good basis grounding in structural principles, which is why I say that I think engineers make better scripters for engineering than maybe computer programmers, if that answers your question or dodges it suitably.
Anybody else? Okay. The other thing that my background has been in education at the Dublin Institute of Technology, and one of the things that occasionally arose during some of our accreditation visits was this business of the continuing development of what, if you like, we call black box technology, where somebody puts an input into it and the result appears out of the other end. And we're back to the question that somebody raised at the very outset, this whole business of QA. Who's actually checking what's actually happening inside in the box, so that the output is what we expect it to be? And I think we're looking again very often that the management of the QA for this whole scripting process is probably something that will raise its head as more and more people get involved in it. But as I said, that's for another day. Just to conclude, I'd like to thank Thomas for a very interesting presentation. Certainly it was something that I had very little knowledge of. I have a lot more of it now at this stage. Whether I'll be able to use it or not remains to be seen, but I have absolutely no doubt some of you will encounter much more of it into the future. As I said, I'd like to thank Tom, and I'd like you to show your appreciation for his excellent presentation.